Hey, I'm Kevin O'Connor, a staff solutions engineer here at HashiCorp, and today I'm going to be taking you through a demo that showcases how to automatically issue and rotate TLS certificates using HCP Vault and Vault Agent. So we're going to see how Vault can act as our certificate authority to generate short-lived certs, and then how Vault Agent could automatically fetch and renew these certificates before then triggering our service. In this case, we'll be using Nginx to seamlessly reload the new keys to make sure that we're maintaining secure HTTPS connections all the way through. So before even jumping into the architecture, you might be wondering, why are we going to do this? And just for some quick background, rotating TLS certificates is really considered a best practice because they're a credential like anything else, right? And we want to make sure that we're minimizing long-term exposure of these certificates or its private key in the event that it was compromised. If we have short-lived certificates, we're really going to reduce that window of opportunity for attackers to be able to exploit any breach, and having a regular rotation really forces a constant revalidation for every connection every time and checks to make sure that revoked certificates are no longer in use, right? Then finally, this automated rotation is going to make sure that certificates remain current with the latest security standards, making your overall security posture that much more robust. So taking a look at the architecture, we really have three different components here. We have HCP Vault and the configured PKI secrets engine. And then we have this server component, that I'm calling it, that has two different kind of subcomponents. One is Nginx, which is our service. And then we have Vault Agent that's running on there as well, too. So starting with HCP Vault, again, this is going to be operating as a certificate authority. It's set up, or I configured it with the PKI secrets engine that issues the short-lived TLS certificates under strict policies. Think about things like issuing certs with a short max time to live, right? And that's going to ensure that certificates are automatically rotated and only valid for brief periods of time. Then on the server component side, and I'm running this, all locally on my machine, but in reality, we can think of this as a server delivering some sort of business critical service, or a web app that you may have. But we have the Vault agent component, which is going to use an auto auth mechanism to vault via something that we call a token file. And there will be more on this later on, as well as other ways that Vault Agent can authenticate to HCP Vault. But essentially, it's periodically going to request a new certificate for a domain that we specify, in this case, web.example.com. It will then write that certificate and the corresponding private keys to disk, actually in our Nginx config file, and then trigger a reload of that service, trigger a reload of Nginx to make sure we're using the updated certs right away. Then we have Nginx, right? And this is serving as our web server, our HTTPS server. But again, you could think about this or think of this like your business's service or app. And it's going to be configured to load the TLR certificate and the key from the location where Vault Agent writes them. And when Vault Agent renews the certificate, it will also automatically call, an Nginx reload command so that, again, Nginx immediately begins using those updated credentials. So all in all, with this sort of integrated flow, HCP Vault is continuously providing new certificates. Vault Agent automates the renewal process and manages the certificate files, and Nginx dynamically picks up and serves the fresh certificates, all to make sure that we're ensuring a seamless, secure connection to our service without manual intervention. And then the last step here is, in the demo, I will, reach out and connect to the service over HTTPS to show that secure connection. But again, this could be a user reaching out to a service, or this could be machine to machine as well too, which is another pattern that we see and support all the time using a flow like this. So that's it at a high level. A couple more things on the back end I just want to go through before we actually get into the demo itself. So let's go ahead and look at the Vault UI. So I have an HCP Vault instance running. This is the UI for HCP Vault. So we can see there's a number of different secrets engines we have for delivering dynamic, or just-in-time credentials. I've got them set up for AWS, Azure, and GCP, cloud credentials for doing deployments. In this case, we're going to be looking at our PKI secrets engine, which is for issuing short-term certificates. And there's just a couple of things in here that I want to show. Under the issuer section, this is where we're going to see, our root certificates, right? So in this case, I generated a root certificate that these short-term certificates will be based off of. So I've got the root here, and I generated that within Vault itself. Likewise, if you wanted sort of an additional layer of security, you could maintain your root certificates elsewhere and import them into Vault. It's another pattern that a lot of our customers use as well too. But here we have a root. I generated it, and again, the sort of leaf certificates that our services are going to use are all going to be based off of this root certificate that we trust. I also configured a certificate revocation list, a CRL, and an issuing certificates URL, basically just to help Vault and clients with that chain of trust validation and revocation checking. A couple of things which are essential to maintaining secure communications, but we don't really need to get into the details of all that here. Heading back out, within the PKI engine, I then created a role called example.com. And this is what's going to establish the policy for issuing these certificates, essentially ensuring that only authorized domains receive certificates and that these certificates have a controlled lifetime, right? So in this example, if we take a look at the config, actually set the max TTL for these certs at 10 seconds, right? So the certs that are generated are only going to be good for 10 seconds. And the cool thing actually about Vault Agent is that it's going to look to renew the certificates at the half-life of the max TTL. So literally every 5 seconds, Vault Agent is going to be authenticating to HCP Vault, getting a new certificate generated, and then writing it to the Nginx config location. And cycling through that every 5 seconds. The certs themselves are good for 10, right? But that process will essentially kick off every 5 seconds from the time that certificates are generated. The other thing I want to just highlight is domain handling, right? In this case, I set it so that the certificates can only be issued for domains within example.com, right? So we have kind of our scope on what the certificates are going to be valid for. Okay, great. I think that's good on the Vault side of things. We'll just head over now to kind of the server side and check out a few things, do a little bit of a walkthrough on some of the code that we have. So here I've got Visual Studio Code just set up in a couple of different config files. So this first one that we're looking at is actually the Vault Agent configuration file that we called vaultagent.hcl, right? And I'll just kind of step through what it is that we have here, right? So things that are required for Vault Agent to work and how the authentication works to HCP Vault, right? So first off, we have this PID file line here, right? And this really just tells Vault Agent to write its process ID to a file so that we can easily monitor and stop it if needed. We then have this auto auth block. So this is how Vault Agent is actually going to authenticate to HCP Vault, right? And I'm using the token file method, which basically just means that I've got a file stored with my Vault access token written into it, right? So it's not necessarily the best in that I'm still using a static credential, but at least I'm not hard coding my credentials into my config. Something I thought worth mentioning though is you can leverage a number of other supported auth methods within Vault, right? If you're familiar with how Vault works, we like to have our customers leverage existing forms of identity for logging into Vault, and it's no different here. So these are all the currently supported authentication methods for Vault Agent to log in or authenticate to Vault, right? So if you're leveraging cloud provider IAM today, you can do that. You could use JWTs, right? JOTs, JSON Web Tokens. You could use LDAP, Kerberos auth. An app role is popular as well too, which is our sort of custom developed identity method, right? That's great for machine identity, logging into Vault. Really, there's a bunch of ways to assign a trusted identity to Vault, not just token file. But I use token file today just for demo purposes because, to be honest, it's fairly simple to set up. Heading back into the config file here, we then have this sync file location, right? So actually, after authenticating the agent, Vault Agent, it's actually going to get a new token that it'll write to a file to use for other processes if needed, right? So anytime anything auths to Vault, token file method or not, it's then given a token with scoped permissions that it needs to do its job, right? So if you auth to Vault with an IAM role, you'd be given a token back with permissions for you to be able to do your work in Vault, right? In this case, we happen to be authing initially with a token, but we're still given a token back after the fact regardless, right? With those scope permissions for us to be able to do our work after the fact, right? It's really just a best practice to separate that initial authentication from the authorization, or what the user or machine should be able to do in Vault. And we'll see that when we start up Vault Agent in a little bit. We'll see some outputs about the sync file, right? About that, getting that token back and Vault Agent writing it to a location to then use for its authentication each time it's generating and renewing those certificates. We then have the Vault block with the address, right? So that's the location of our Vault instance, fairly straightforward, and the namespace that we're going to be operating in, which in this case is admin. And then we get into the fun stuff, a couple of these template blocks down here, right? So this is where our automation really comes into play. In the first, the agent will fetch a TLS certificate from Vault that includes the chain for this CA, or the CA chain for, in this case for web.example.com. And it's going to write it to the destination that we have written here, right? It's essentially going to write the certificate to that location that will then be used by Nginx. Then after writing it, it's going to issue this command to reload Nginx so that that new certificate is immediately being used. The second template block follows that same sort of flow, but we're essentially retrieving the private key this time from Vault and then writing it to the private key location that Nginx will pick up right from there. And again, issuing that reload command to reload Nginx to make sure that that's being used immediately. So that's it for Vault Agent. I did want to highlight something on the Nginx config side real quick, right? So there's a default server config with Nginx, but we just had to add a couple things to make sure that we're able to serve, web.example.com, in this case on localhost, right? So taking a look at this, just a couple things. So we've told Nginx to listen on port 8443 for SSL connections, right? But then almost more importantly, we have this server name directive, which tells Nginx to match incoming requests for web.example.com, right? And that's really critical for two reasons, right? It's going to ensure that the certificate we issue from Vault matches the host names used in the request, or that the request matches the host names in the certificate, right? And it's going to allow us to direct traffic appropriately, right? If a client requests web.example.com, then this block is going, or this config is going to be used, and therefore these certificates down below will be used as well, right? So we have these SSL certificate and SSL certificate key directives that point Nginx to the locations that Vault Agent manages, right? These are the locations we just looked at before, where Vault Agent is writing both the certificate and the private key respectively, right? And then we have this location block down below that basically, defines behavior for requests to the server. I more or less wanted to get, a success code outputted on the terminal if we have a successful secure connection, right? So if we connect over HTTPS, right, using our TLS certificates, we're going to get a return code that says, a return on the terminal that says, hello from Nginx over HTTPS, just to verify that we're serving encrypted traffic using our dynamic certificates. Okay, so that does it for the config. Now let's check. We'll check out a couple things. We'll get into the actual demo now. So I have a couple of terminals running. I'll try and keep this as simple as possible, but one of them we'll be using to watch the outputted certificates. One we'll be using to run Vault Agent, and one we'll be using to issue curl commands. All right, so for starters, let's just take a look at the location where we are writing our certificates to make sure we don't have any long-lived static certs that are there today. So I'm just gonna run this and we can take a look. This is just outputting the latest certificates that were written to the location that Nginx is using for a certificate and private key, right? And we can see that there is a cert there, but it's actually expired as of March 25th, right? At 8:41 GMT, right? So if we were to run, this is a date command, we can see, right, the current date is Thursday, March 27th, right? So it's a couple days ago. So the certificates that are currently there, or the cert that's currently there is expired, right? Now, to really be sure, like, why don't we go ahead and try and actually connect to our service and see what happens, right? So if I'm going to run this curl command, and essentially what we're doing here, is we're curling, right? So we're trying to connect via the command line to this this address, webexample.com on port 8443, right, running on localhost. And then we have a couple flags here as well too that I'll call out. So right, so it's not a straight curl. There are a couple things we're adding in. The first is the CA cert flag, and we're calling on rootca.pem. So this is actually telling curl to use a locally downloaded root CA certificate to validate the server certificate, right? We're basically saying that rootca.pem is our root certificate. And if we're evaluating any certs that come from that root certificate, that we should just trust them, right? Typically, you wouldn't have to do this. Typically, you would have imported the root CA into your trust store, but I just downloaded it locally for ease so that we're evaluating it directly on the command line. I could have added this root certificate to my system trust store, right? Or if you're connecting to it over a browser, maybe you add it to your browser's trust store, right? But for demo purposes, I just don't want to be adding some kind of random demo cert that I created to my system trust store. Who knows what could happen down the line. It's easier for me to just download it locally. We'll evaluate it, on the command line, and then I can go ahead and, delete it after the fact. Then we have this resolve flag, where we're resolving or we're basically forcing curl to resolve web.example.com as localhost on port 8443. So basically the host name in the URL will match the certificate subject, which we really just need to do, otherwise the request wouldn't be recognized. So that's the command. So let's go ahead and we'll run it, and we should get an error, right? Which is exactly what we're looking for. So there's a problem with the SSL certificate. It's expired, right? Which is what we just checked on. So, right. So we can't connect to the service because we don't have a valid TLS certificate. So just to show, I've got nothing up my sleeve, right, to start. Now, let's go ahead, and I'm not sure if I actually did this beforehand. We'll just want to start Nginx, make sure that's running. It's already started. Great. Let me just go ahead and I'll restart it. Should get a stop start there. Okay, fantastic. Great. Now, one last thing is that I worked up just a simple script that's actually going to monitor that location, that Nginx config location, for new certs as they're generated and written, right? So I wanted some way for us to be able to watch, as the certs, and we'll see this within the output of Vault agent, but there's a lot of information that'll come through the terminal here. So this will give us an output every time new certs and keys are written. They'll be outputted on this command line over here, or in that terminal over there, along with the expiration dates for those certs and keys. So essentially what we'll see is certs and keys starting to come through with expiration dates that are about 10 seconds apart, right? So I thought that's kind of just a nifty way of being able to showcase what's going on behind the scenes. So it's called watch certs. We'll go ahead and get that running, and the script is running. It's basically polling that location every 2 seconds on the background. Okay, now I'll make this a little bigger down here because this is going to be Vault agent, and we should get a substantial amount of output that we'll just want to make sure we can keep an eye on. So here's the command to get Vault agent started. We're running it as sudo, right? So kind of escalating our privileges, running as admin, Vault agent, and then we're specifying the config file that we just reviewed, right? So that Vault agent.htcl config file. So, okay, so just to step through it once more before I kick this off, right? So Vault agent is going to start up. It's going to use this config file. It's going to use that auto auth block to read a token from a local file I have saved in my workstation. It'll then connect to HCP Vault that we looked at before in the admin namespace, and it'll authenticate. Once it authenticates, it will request a TLS certificate for web.example.com from the PKI engine, and it'll write that certificate and private key to the designated file space in the Nginx SSL config, right? And then it'll execute that reload command to make sure those new certs, right, those new credentials are immediately in use. And then the agent, Vault agent, is going to continuously monitor and renew the token and certificates to ensure that the server always has current and valid credentials, all without manual intervention. So once we kick this off, the automated flow will all go through. So let's go ahead and put my password in. And here we go. So let's see. So a few things going on just to take a look here, right? So we created that sync file. We're writing the token we received back to the sync file so that Vault agent can use it. And let's take a look at a couple of other things that are going on. So the first certs that are being generated, I believe, yeah. So the Vault write commands are actually what are being used to generate the certificates and private keys. In this case, this is telling us 1 hour is longer than the permitted max TTL of 10 seconds. So there's a default of 1 hour in the system, but we set it to 10 seconds. So 10 seconds is what's being used. That's all that's telling us there. And then we're getting the certificates and private keys back, and Vault agent is writing them to the locations that we looked at before, right? And then we're issuing a reload command. And then that cycle is continuing over again and again, right? So we're getting our Vault writes to issue the new certs and keys. We're then writing them to the locations that Nginx needs, and then we're issuing a reload command, right? We are performing our Vault writes to generate the certs and keys, writing them to the location Nginx, issuing our reload command, right? So that's kind of happening, cycling through time and again. And if we take a look, I'll scroll up here. If we take a look, once I kicked off Vault agent, right, we started getting some outputs here for our certs and private keys. And then it's basically telling us certificate validity, not after March 27th, was that 7/10/04 or 19/10/04 GMT, right? So that's the first one. Then let's step down. So we got another one, 19/10/14, right? 19/10/24, right? So pretty much 10 seconds apart, right? 19/10/35. Okay, so there's a little variability there, but essentially 10 seconds apart, right? 19/10/43, right? So the certs are being generated, being written, and expiring all within 10 seconds. On the Vault agent side, every time we're dropping down to 5 seconds left on the TTL, it's all thanks to Vault generating the new cert and writing it out there, right? So that's the flow. And really, in reality, are you going to be generating certificates every 10 seconds? No, right? Most of our customers, it kind of range from renewing certificates every, I'd say 24 to say 72 hours, right? In practice. But for demo purposes and to showcase kind of the power of the system of what it's really capable of, to get some good output on the command line that we can review in a demo, I think every 10 seconds is pretty cool to see, right? So great. Now let's go ahead and test out our connection again, right? So let's try curl out to our URL. And if we're successful, we should get that success code returned, right? And there we go. Hello from Nginx over HTTPS, right? Great. So we're using the valid certificate that's in there now. Fantastic. So that's about it, right? We can see this is continuing on. Now, if I was to go ahead and kill Vault agent, let's go ahead and stop that. The last cert, 26 seconds, should have actually just expired. Let's go ahead and try and connect out there again. Boom. Exactly what we're looking for, right? So SSL certificate problem, it has expired, right? So it's exactly the behavior that we're looking for. So that is it. Hopefully today's demo showcased how we can automate the lifecycle of TLS certificates using HCP Vault and Vault agent, where we have Vault serving as our certificate authority to issue these short-lived certificates, and then Vault agent continuously monitoring and renewing these certificates before then writing them to disk and reloading our service to make sure that the service is constantly using the updated certs, right? And if there's one thing to take away, right, it's that this sort of seamless process minimizes manual intervention. It'll increase your security and reduce that attack window and ensure that our services always use valid, up-to-date credentials. So that is it. If you have any other questions, please feel free to reach out to me or your account team, and we'd be glad to talk to you about this in more detail. Thanks so much.